we'll bring up Luca. Hi, Luca. He's in the bottom left
Hey,
corner over
hello.
there. Hi.
Good. So nice to meet you all. I'm Luca. I'm the lead sales engineer and solutions architect at SignalWire. And today we'll be going through an introduction to Relay. Relay is our main innovation in the API space at SignalWire, and it is a real-time call control protocol that allows you to do many things and it allows you to build very complex workflows with a little bit of code. So should I start sharing my screen now? Okay, cool.
Yep,
So
go ahead.
Cool. So we'll be going through a few steps along the way to finding out what Relay is and what it can do for you. First thing is going to be, well, simple introduction to what Relay is. We'll look at how to install the SDK that we support in many languages. A few nomenclature and concepts steps, because we do have a few terms to learn before we can go forward. Now look at the main call object and the call method it has. Find out what a relay task is. Look in particular at how we detect machines and faxes, which is very useful and important for many applications. And finally, look at messaging. So let's see what we can. So what is relay? We're all used to HTTP-based APIs where when you receive a call, the server receiving the call will place some kind of a webhook to your application, and your application will respond with whatever maybe XML or instructions the call needs to take. Or in case you're placing an outbound call, what you do is place a HTTP request to the SignalWire server, and the SignalWire server through REST will take care of making that call. Relay is completely different. Relay is based on a WebSocket connection, a secure WebSocket connection, and it's persistent. So the connectivity is already there and uses a JSON payload to communicate. That makes it very low latency, meaning that each interaction is noticeably faster than if you're using an HTTP server through LAMO. That's something I've seen it's really noticeable in interactions such as call center operations or moving people from one call to another, what is in general pretty slow. The protocol is also self-load balancing or reconnecting. Each client, called the consumer, has the ability to distribute calls between them and also reconnect if something bad happens. Just taking a look at the quick payload example, because so honestly, you won't necessarily need to deal with the payload ever. Our SDKs take care of the actual structure, but it's worth looking at. In this case, we're seeing that we have a requester, which is the client you registered, calling to a protocol. There's many protocols. Protocol we're looking at is actually a telephony protocol. The method we're using is the calling.begin method and has some parameters. The tag is something you'll use to retrieve the call from, your list of usage, listing calls, things like that. You're asking the call to be placed on the US region, and the device you're dialing at is a phone. It can be a SIP device, a phone, or a WebRTC client. The parameters, of course, then are pretty self-explanatory. You're dialing out from a certain number. Keep in mind, caller ID from the from number has to be one number you either own a SignalWire or has to be registered with SignalWire through a verification, and that's something we looked at in the previous workshop, and there's a guide that goes about it. So if anybody has any questions, we could go back to that very quickly. Two number is going to be the number you are dialing into, and timeout is how long the call will ring before it will hang up. But don't worry, we'll see the same thing in action, but in the context of the actual SDK, which makes it much easier to work with. So I went with the Ruby SDK. We have support for many other languages, which are C#, Python, PHP, Node.js, and Golang. I went with Ruby because I find it readable and it's usually a good starting point, but really each of the SDKs has full documentation, as all you need to get started. So few words we encounter during our journey. So I like to set the stage when we do this kind of workshop/training, so people are aware of what we're looking at. So a consumer is going to be our main entry point into Relay. A consumer is a class you write in your favorite language that connects to the Relay system and waits for something to happen, whether it's a call coming in, it's a message coming in, it's a task coming in. And that's going to be what you generally write when you're working with Relay, a consumer. There's also another method which involves using the raw client, but that's more reserved to advanced usage, or maybe if you're building something that the consumer doesn't support yet. Because, of course, like API libraries, Relay is built in layers. Sorry?
Hmm? Why do you want to see the participants?
Relay is built in layers. So there's a core that's the various components and events that you usually shouldn't need to even touch. The client, which is the low-level protocol and wire operator that allows you to do things at the lower level, and then consumer is an easy-to-use class, helps you go into the various clients. Sorry, I changed the last mistake. Back. So quickly, a call is just a phone call, sync and async. So Relay compared to HTTP has a very interesting and important use case, which is the ability to do operations asynchronously. So you could be playing audio and then doing something, maybe database lookup that takes time. So you could be looping some audio saying, please wait while we find your data. And then when the database actually finds the data, you can just stop the playback and resume execution. The detector is a very important and interesting part of Relay because it's different than the one we use for the label side, and it's able to do speech recognition, digit recognition, fax detection, answer machine detection, and some other advanced use cases. Lastly, we'll see what a task is. A task is the best way to communicate with your own consumer in a way that's working. Okay, good. So first consumer. This is where it gets interesting. So we require the SignalWire library. I'll be omitting the required SignalWire line from now on because it's just standard Ruby. And we're creating a consumer inheriting from the SignalWire Relay consumer class. First thing you see is that we're setting I will say a class array. Context is actually a method. And we're giving it a list of contexts. Currently one context. Of course, it could be multiple, in which case it will just be an array. So what a context is a just a label for actions and things that are happening on the relay side. So registering with the incoming context means every time a call comes in to the incoming context, and we'll see what that means in just a minute, the call will be transferred to this consumer, or rather to one of your consumers that are registered using the same context. Because if you have multiple consumers registered with the same context, the first one to pick up the call will win, and they will effectively automatically load balance each other. So what a context is actually just a label. And I have set it up here to take a look at. So I'll just get one of my phone numbers, any of them, edit the settings. This is the SignalWire dashboard. Maybe I'll make it a little bit bigger since the video is not super clear. Okay, so right now this endpoint is set up to send calls to a phone number, but I want them to go to my relay system. So when I pick relay, I will just, when a call comes in, forward call to this relay context, incoming. Simple as that. Now if I save, anytime someone calls this number, the call will be sent to the relay system, which will in turn find a consumer registered using my API key and registered for receiving calls from the incoming context and forward it to the consumer, which will do whatever. Configuring a consumer is pretty easy, actually. I didn't actually make a slide for that, but that's super easy, so I'll just show you here. So all you need to do is you can either specify these parameters explicitly, or you could be doing you just need to set up project key and a SignalWire project key and a SignalWire token as an environment variable. That's your choice. A from number and to number is not required. There's just something I'm using to see if I can make it even bigger. Yeah. From number to number are just environment variables I'm using myself, but you can either set these or pass them at initialization time. So when you create the actual consumer and use it, that's your choice. I generally use environment variables because they're simpler and make code all the much readable. As you can see, there's no reading environment variables, etc. here. So Going back, so we've seen how to register a phone number. Well, not register a phone number, but how to make the phone number forward a call to a context called incoming. So when I'm running this consumer and a call comes into that phone number, I will get it into this on incoming call method, which is part of the consumer definition. Of course, this has to be implemented, otherwise it does nothing. But in this case, what we do is we answer, we play some audio, just hello world, and hang up. This is classic hello world example. As you can see, the on-incoming call suggests a kind of an async handler itself, which is actually true. So if you receive multiple calls, any number of calls, you're really just limited on your how many cores you're running and how you're set up exactly. As an aside on that front, given that most of the scripting languages, so Ruby, Python, and JavaScript, have a global interpreter lock that allows you to only use one core at a time, my recommendation will be to run one consumer per core to increase your throughput instead of running one consumer on a larger machine, because having a larger machine will really not help, while having multiple consumers will help in the sense of giving you more throughput. Each consumer can handle a lot because it's not really touching the call, it's just passing JavaScript back and forth. So, sorry, JSON, not JavaScript. It's only passing JavaScript back and forth. So it's really a matter of just getting it to perform as you need. Another thing it could show you is here how. So let's take a look at what happens when I run a consumer in the console, just so we can see what's happening with Relay. Again, you will never generally need to do what I'm doing right now, just looking at the wire. This is set up to do full debug. So what you're seeing is everything is getting exchanged between the client and the server, but it's always worth taking a look. This will just place a call to my own phone here. Maria's ringing. And this just says the quick brown fox from server lazy dog. So we'll go quickly take a look at, so this is the authentication exchange. There's a lot going on here, but the example I wanted to show you is really just this. So two of them really. So this is the first important message here. And this is, as you can see, the call and begin, the tag, etc. we saw earlier. And then we're seeing that it's placing a call from one of my numbers to another phone number. So when the call is answered, what happens is that it just plays audio. Let me see where that is. Well, as you can see, we're getting plenty of events, including that the call is ringing here halfway through, telling us the call is ringing on an outbound call, which is that also, well, you have the call ID too, but also you have other information. Call is being answered because I picked up, and now we're executing a play. This is also interesting. Again, we're going to go through this in the context of the SDK, but it's worth seeing what's going on behind the wire for just a while. We're calling the method call and play with TTS. Parameter is the quick brown fox, some sort of lazy dog. Language and gender are left actually default. So this is what's happening behind the scenes. All of this is simply generated by this. So let me show you what that looks like. This is part of the standard SDK examples, but worth looking at. As you can see, so if you ignore the first part, which actually just sets up the examples to work with the SDK, the example I did is very simple. When the consumer is ready, it will place a call and play TTS when the call is answered. Dial effectively waits for the answer too. This might look like a good example, and in fact it is, but it has a problem. This consumer will not do anything else other than placing the call when it gets ran. So effectively what you need to do is then stop the consumer and run it again if you'd like to place the more call. Since that's not very useful, we'll go over a method to make a consumer place outbound calls later through the concept of tasks. But let's go back to take a look at what a consumer can do for you. What's important, and we'll see a few examples here, is sync and async methods. This is totally new and exclusive to Relay when it comes to SignalWire APIs. Relay allows you to do async method calls. That is, it allows you to execute any method on a call and continue execution instead of waiting for the result. What's important here is keep in mind if you run a method asynchronously, code execution will continue. So if you have something after that, say you have a play and then you hang up and you don't have anything holding up the code execution while that's happening, what you hear is just maybe you hear a split second of the audio and it will hang up. The example that we have on the right is a good use case. So we're playing some audio asynchronously. As you know, as you can see, the async is marked by the bang at the end of the method name. And the lookup is populated with some slow method, which is just made up. Assume that some slow method, I don't know, is looking up your balance on a system that's a legacy system that's very slow. In this case, you can keep playing audio for the user until you're found whatever you need to. Sometimes you're not able to. So what I always recommend is if you have a slow method, make it fast. But it's not always possible. If you're dealing with legacy methods, APIs you don't control, you might end up having something. We do. I recently worked with a customer that had a similar problem. So they're asking an external API for some data, and it's taking split seconds and sometimes and few seconds others, up to 5 or 7 seconds. This makes it so that you can play a long audio file while the database is working. Then you stop the play action, so effectively stop playing the audio, and then the example is just saying whatever. In this case, it will be something. Hello, Mr. Luca. Your balance is $100. Would you like to add more or whatever? This will come back in a few examples that we have down the line. We've seen audio output, and there's a few examples I can give you. Really allows you to play text speech. Also allows you to play silence. Playing silence is maybe something that sounds silly. Like, why will you play silence instead of just using, I don't know, sleep and waiting for 10 seconds? The answer is that playing silence keeps media flowing and prevents gateways that might be in the middle from timing out. Asterisk is known to time out if you will be for most default configurations for switch for free PBX, sorry, not for switch. Most default configuration for free PBX will actually time out if you have no media flowing. So playing silence is preferable because it actually keeps keeps zero content RTP packets flowing. So there's audio only with silence. You can also play audio, and it has it's audio doesn't have many options other than just the audio file you pass it. It will play MP3 and WAV files in many formats. What else? So let's see what happens. So what we want to do generally, if you're getting an incoming call, you might be wanting to call another phone. This is actually quite important. So what I'm showing here is the full example of a connect call. There's a couple of shortcuts in the documentations that allow you to write a little bit less of code. But what you're seeing here is exactly what you saw in action in the console before. So we're calling out. So call in this case is our incoming call, and we're connecting it to another destination. So effectively what happens here is that I dial the number, and the number was in turn dialed into another. So essentially what I'm doing is I'm talking to this 12020 number. Actually, that number you see here is a talking clock for the Washington, D.C. Naval Observatory. So we'll just give you the time and weather in D.C. if you ever need to go there. And jokes aside, you have usual suspects such as timeout and a few other parameters. What's important is take a look at the lines that follow. If the call is connected successfully, you can wait for the end of the call. Effectively, that will put the entire flow in a waiting state and make it stay there until the call is completed. Otherwise, it means the call failed. I just put in a comment saying failed to connect, which might mean you might wanting to do whatever. For example, you might be wanting to record the fact that the call failed and then just hang up. That's the general structure of the connect method and how to dial out to a second destination from an inbound call. So again, this example is about I am calling the number we configured before. hits my relay consumer, and my relay consumer makes me talk to the Naval Observatory in Washington, D.C., or maybe something more interesting. Another important interaction, and one where relay really shines, is receiving input. Relay has the ability to receive digits and speech input at the same time too, in which case you're even able to check for type. So essentially, if someone entered digits using their TMF keypad, you will know it's a digit, otherwise it will be speech. We are generally using the prompt method. So there's a prompt TTS method, prompt audio. Those methods combine the output, which is, for example, as you can see here, we're asking for please enter your 4-digit PIN with a voice that's male gendered, and we're wanting a maximum of 4 digits, and we're waiting for a timeout of 5. That is, if someone enters 1 or 2, 3 digits, then waits, or 0, after 5 seconds, we'll time out, and the result will not be successful. Continuing down the line, of course, we'll see that if the result is successful in the digits collection space means we have 4 digits. So it matches what we requested. The digits are in the result.result parameter, and I added a comment that says watch for this, because some people will go through the result object. Actually, the object returned from prompt TTS as a result method that will give you whatever was entered in case of a successful input. They just gotcha. You can just look at examples, but it's worth knowing. And then I added a made-up method that uses the call dot from property. So the call object has many properties, including which number it comes from, which is the simplest one. And this way, we're effectively, we're checking that that caller and that pin match, and then we'll do something with it. Just example logic. I just wanted to show how to use it. Speech recognition. This is also very interesting. So first of all, I'll digress very quickly. Relay has a very powerful speech recognition and answer machine detection mechanism that spans a few different providers to give you the best results. So I encourage everybody to try it, because it's really, really cool and works extremely well, both in freeform inputs, but it's effectively even better when you're doing hints detection. That is some kind of a list of words. For example, what you're seeing right now here is an open-ended detection where I'm asking the person what their favorite car is, but it could also be a question like, would you like to talk to sales or support? In which case, you will pass a list of hints to the method. We can take a look here. There's a couple methods that are worth taking a look on the main documentation. As soon as main object here is the relay call, and the method I want to take a look at is prompt. As you can see, there's many parameters here. You can do both voice and DTMF input. Speech hints is the parameter you want to specify a grammar. So just specify speech hints with an array and say, I'm waiting for the words sales or support, so that the grammar can be more precise. If you specify hints, I've never seen it fail. It's very, very effective. What else? There's so much here. So I'm just trying to go through a few examples, to a few main methods, and then we go through a couple interesting examples, just so you have a overview of what we're doing. The more complicated stuff we'll leave for a follow-up a webinar, because there's a lot here. Recording. So recording has an ability to be configured in many ways. You can use timeout detection, you can use voice activity detection, or you can use a press terminator. In the case you're seeing here, the recording will terminate when the user presses the pound key, or if the call is actually, I think after 30 seconds should be the default. Again, if the result is successful, we'll do something with the URL of the recording. When you're doing a recording, what you get is a URL in MP3 form from our cloud. So then you're able to download it, delete it, whatever. But we're checking that the recording actually succeeded before we do anything with it. Tap. This needs a bit more explanation. So up to now, we've seen that Relay allows you to build more or less any kind of IVR that you could already build through Lamor, right? It's not really doing anything fancy other than being much more responsive. So if you're doing a high interaction IVR with many questions and turns, Relay will make it more enjoyable to use because the time between input and output will be faster. Generally speaking, relay latency is not higher than 50 milliseconds unless you have very bad connectivity. But if you're running on any kind of virtual machine that from the usual suspects of cloud hosting, you shouldn't have any problems. This is Tap is one of the coolest things you can do with Relay, and we actually have customers using this to do artificial intelligence assistance inside a call. So what Tap Media does is it allows you to send one leg of the call or both legs of the call to a endpoint using either raw RTP or WebSocket based audio. This allows you to have, say, a speech recognition engine running continuously on your own servers that then has the ability to intervene or maybe transcribe the call or many other things. For example, a couple examples we have in real life are a customer that's using this to do real-time sentiment analysis on the call. So they only listen to the audio coming from the call person. This is a call center situation. So they don't listen to the audio from the agent. We should be happy because it's working and it's bound to be happy by contract. But they're calling out to someone, and this someone might have something to say that's good or bad, and they do real-time sentiment analysis on what's happening in the call so they can give hints to the agent. So effectively what they're doing is they're detecting the tone and the wording that's being used to see if the person is getting frustrated with the interaction and then intervening in some various ways. Another customer is actually using this to place to interact with a order, so food orders, and they're doing it so that they can actually find out if the other end is correctly interpreting the questions and answers. And ultimately, I think they're placing tens of thousands of orders a day right now, effectively enabling restaurants who don't have a website and don't really have a subscription to many of those delivery services to take orders and through the phone, essentially. This is very cool, and it's something that it's being used by many people and it's considered very useful. Cursor now. Okay, so right now, up to now, we're talking about only about inbound calls. As you can see, if we go back just briefly, we see that all of our interactions have been based on the on-incoming call mechanism. Earlier again, when I was showing you my example, I showed you a sample from from the SDK, and I said it was not very proper because what that consumer does is when the consumer is ready, it places one call to a phone number, period. That's not usually what you want to do. It's great for testing. It's easy to do when you're just placing one call to yourself and seeing if your consumer is actually working. But the way to interact with the consumer, which is I want to remind you that consumer is a long-running process that's running standalone on your machine. So you have to find a way to interact with it to make it place outbound calls. Say you have a call center, you want to place calls outbound, and when people answer them, you want to connect them to agents. How do I place a call when I fetched 100 calls from the database? How do I give them to the consumer so they can be dialed out? The answer is using there's a few solutions actually. We offer a spoiler user-related tasks, but still, you could be doing a couple other things. You could be using in-process communication, which in Ruby will mean using DRB, which is a nifty mechanism that Ruby has for sharing objects in memory and allowing them to call methods on each other. That actually works quite well, but has the problem of only being limited A to Ruby and B to same machine communication. Distributed DRB is really terrible, so don't try to do it. and also has the problem that it doesn't really handle reconnects or whatnot. So if one of your processors goes down, I don't even know what happens. You're generally left in an uncertain state. Better will be using a processing queue of sorts. So your consumer could be polling Redis or a M2P queue, and when an event comes up, they might be placing calls. This is a legit way to go about it, and it's something that we have many people doing. But the recommended way, as I spoiled earlier, is using relay tasks. Relay tasks are a lightweight message mechanism that your client can send to the SignalWire server. SignalWire servers will then distribute it to one of the connected consumers. That is, one of your consumers that are on the proper API key, of course, and also have registered to your to the correct context. So if you want to send a task to a context called incoming, there has to be at least one consumer that has registered using that context incoming line that we saw earlier. Let's see, first of all, how we will register for a task. You remember we were using onIncoming call as a method up to now. Now we're switching to use onTask. Note, you can use both. Consumers don't have to be one way or the other. You could have a single consumer handling both inbound calls and tasks, and in turn doing outbound calls. There's nothing stopping you from that. I'm just separating examples from the sake of being clear. And also, if you split out consumers by functionality, in my opinion, you get a better chance at scaling correctly when you realize you need more of each type. You don't necessarily have to pull up all of it to increase the numbers of all of it, but just spin up extra instances of the ones you need. Going back to the task at end, which is actually a task, when we receive a task from the SignalWire server, it will have a message property. The message property will be a hash that of whatever was sent on the other end in JSON. We'll see that in just a second. So that means you're not only, of course, it will not be very useful if you cannot do anything with the message itself. Your main use case will be telling the consumer, for example, what number to call, as is in this example. Is there a way to change it? Oh, there's a question here. Is there a way to change the consumer's context without restarting it? No, actually not. But consumers go up in milliseconds. So actually, official answer is no. You can do that if interacting with the client directly. So if there's a need for that, and you end up having a need for that, let me know, and we can come up with some more complicated example. Because actually registering from context could happen at any time. So you could technically re-register with different contexts. It's just something that the consumer doesn't expose because it's supposed to just be up and running. But not from the consumer, but it's possible. So going back to what we're doing now is we're just dialing out to the call. As you remember when I showed you earlier, dial actually also waits for the call to be answered. So you're sure that the call is answered by the time this dial method returns, and then we'll do whatever, play TTS, hello for SignalWire. This really not too much, but it's important. So now we'll find out how to react to a task. But how do we send a task to the SignalWire services? As I put in the slide, this is not a relay consumer. It's really nothing to do with relay. The SignalWire relay library includes a task class that you can spin up by using new. As you see, you do have to specify the configuration variables explicitly when creating a task. So we'll remove that need in the next version because it makes it easier. But the code you're seeing is not really part of a consumer. The code you're seeing could be in your Rails controller. The code you're seeing could be in one of your Sidekick jobs. Anywhere you need it, it's just plain old Ruby object, PORO. What happens here is that we instantiate the task, and then we deliver the task to the incoming context with a message that's just JSON. So if you put in a hash, it will be converted to JSON and sent over. This allows you to deliver any kind of information to your task handlers, and allows you to do anything you'd like to do, really. We'll be using the concept of using task to dial out calls throughout the rest of the webinar because it's sort of useful in general. So let's get to the meat of it. This is starting to get interesting. So, as I said earlier, Relay has a very powerful answer machine detection mechanism built in that allows you to do a lot of interesting things with AMD. The simplest example we can take a look at is simply detect a machine and play a message if it's a machine. So record a message. Note that we're using wait for beep true, which means that this simple call will call into a phone number that, as you see in the row in the line before, oops, as you see in the line before, is specified in the message too. So we're telling it call this number, and then wait timeout for with a maximum of 10 seconds, and wait for the beep if it's a machine. So what happens here is that the simple call is actually quite complex. How does answering machine work? First of all, that machine detection work. First of all, just a few a few information points for people who are not very familiar with it. Answering machine detection is generally done through speech and silence periods recognition. When a human answers a phone call, they will usually say hello and then wait for a few seconds, and they maybe say hello again. So that's when there's nobody speaking on the other side. And also, a human will usually take longer to answer a call. That is not when a call is ringing, because answering machines will usually ring a few times before they answer. The time between the call being picked up and someone beginning to speak is actually usually faster when it's an answer machine. So this is the first information point. If someone starts speaking right after they pick up, it's probably a machine. Then if they say something long, a long sentence when they start speaking, that's also a sign it's a machine. And there's others that are important. We also use other technologies that are incorporated in the Relay AMD system, so that will give you a very good result. So what we see here is when I call into the number, I will uh, set myself a maximum of 10 seconds to decide if it's a human or a machine, if I cannot determine it earlier. So if someone picks up quickly because they have earphones already in, and then they start speaking and saying something. Hello, this is Luca. I'm the lead sales architect at SignalWire. Please speak. How can I help you? That's something that's very borderline between a answer machine and a human. So we'll wait for a while more and see if it can. The system will wait for a while more and see if it can gather information about if I'm a human or a machine. But anyways, in maximum 10 seconds, it will decide. If it decides before that and it decides it's a machine, the system will actually wait to hear one of the standard beeps of answering machines. So it allows you to leave the message exactly at the time the answering machine is allowing you to speak. This is very important. This is something many of our customers use, and one in particular does medical calls. So they're actually reminding people they had an appointment, and those appointments are in most cases critical. So they actually need to be sure they left a message on the answer machine. So they do that using wait for beep. Otherwise, you could be using sleep or some other thing. What's the trade-off? Our answering machine system is very quick, but as we discussed, it does have to wait for a few seconds to decide if the called party is a human or a machine. For example, just determining the fact that I pick up, I say hello, and then wait, will take 3-4 seconds before I'm sure it's a human. So in those 3-4 seconds, we'll get back a human result and we do whatever. So answering machine is great, but on the other hand, sometimes it's just based on whatever the other end says. There's no other way to determine. So sometimes it can be slow. Of course, what you're saying here, going back to the original topic, is we're dialing out to a system. If that endpoint is a machine, we'll leave a message saying, hello, we tried to call you. Of course, the message will usually be more interesting, but that's it. Note that you can also do this, which is pretty important and cool, in inbound mode too. And you could be doing this to screen robocalls. So what we're doing here is robocalling, and we could have someone else using the same relay protocol to screen robocalls, and it's something that's actually happening. Because if you do answering machine detection on an inbound call, any recurrence machine, it's usually either someone that cannot stop calling, it cannot stop speaking because they really like the sound of the voice, or it's a machine. Because usually robocall will say, hello, we're reaching out to you about this and that, and we'd like your opinion on this and that. And that will get back as a machine. So that's an interesting use case too. Same thing goes for faxing. Okay, same thing goes for faxing. You could either do a fax detection inbound, which is usually useful. So what we're doing here in this case is we're dialing out to a number using a task. If the number is a fax, we'll send the fax. So fax detection uses the various international and US-based tones. It's got many options you can go about with, but generally speaking, detect fax is smart enough in most cases, unless you're dealing with very weird foreign fax machines, in which case you might need to specify the exit beep code that country is using. But generally speaking, detect fax works very well. So what you're doing here, I'm calling into a number, I'm checking if it's a fax. If it's a fax, I send the fax to it. What's funny is that you could be doing answering machine detection and faxing detection in the same way. So if you're calling into a number, if it's a human, I'm going to talk to them. If it's a fax, I'm going to fax the document to them. And if it's a answer machine, I will leave a message. There's no escaping. Hence, I will say that building that robocall screener using relay will be a very good idea. Otherwise, this bots will take over. Call detect fax is not considered AMD. Okay, so as far as pricing, again, you could be doing the same thing in reverse. You have a number that receives phone calls, and you could be wanting to detect the fax. So if you know the number occasionally receives faxes, you could be doing a detect fax on the incoming call, and then if the call is a fax, receive the fax. Otherwise, talk to them or whatever. It's a very simple way to have one number handling both fax and phone calls, which is actually quite interesting and not at all a given. It's probably not the super interesting, not a super useful use case, but for people who still use fax, it's very important. You probably can tell from my accent I'm not originally from the U.S. and in Europe faxing is not very used anymore, but the U.S. has a legal requirement for especially healthcare and insurance to use faxes. So while my gut feeling will be to turn all of the faxing APIs into responses that just say, please use an email instead, I understand that needs to be used. And SignalWire has a very robust support. And this dual mode fax detection system is something that's probably unique in the industry and will allow you to have one phone number that can receive both phone calls and faxes. Okay, so quickly going through messaging. Messaging is very simple, and I'll be very honest. Relay is well suited to high throughput, complicated interactions that involve async fax detection and tapping the audio out into an RTP endpoint, which in turn generates the sounds needed to send the fax to whatever or some other exoteric solution. If you're doing messaging, you might want to use the HTTP API just because messaging is generally a fire and forget affair. So when you're sending out the message, you just send out the message. And when you're receiving a message, you usually either just want to respond to the message or do nothing, just save it to the database or whatever. So generally speaking, messaging is going to be a use case where relay is less useful. Still, maybe you're already using relay for other stuff and you want to use messaging, or you want to use it in the same context. That is, not a relay context, but a application context. I receive a phone call, and as part of ending the phone call, I want to send a reminder to the person calling in. So I'm calling in to book a hotel. Relay handles all their interaction, the speech recognition, even dials out to another API, to another voice machine to leave the message that I want to record. I don't know. There's so many things you can do. But then you also want to send me a message that's a reminder. That's how you would do it. Sending out the message is very simple. As you see, again, we're doing it in the context of a task because that's what makes the phone most sense. You will usually have a consumer that is waiting for a task that says send a message. On task, we'll send the message using client.messaging.send from to test. As you see, I'm using the 2 number from the message and I'm sending the body from the message too. And then we'll simply doing a debug of the message ID was successfully sent. If result successful, of course, this is where you'd log the message was sent. So what does a message being sent successfully mean? It doesn't mean the message, this is worth saying in general, not just for relay. It doesn't mean the message has been correctly received by the other end. It simply means that the message has been sent to the, simply means the message has been sent to the carrier. If it was delivered, etc., it's a separate request. Note that the message that's being sent to a known text-enabled line, such as a landline, will fail here. So you will know here. And most message failures honestly happen at this level. If you're sending a message to a number that's not capable of receiving text, that's where it will fail. It's not going to fail. It very seldom fails at the delivery level. Receiving a text is pretty simple. So as you remember, up to now, we're using an incoming call method on the consumer, which gets triggered when a call is inbound. Predictably, an incoming message, provided you are registered to the correct context, will get you a message object that really has a from, a body, and a couple other things in it. Again, if you setting up this to well, refusing to help me out of this kind of thing. Okay, I'm free. What I wanted to show you is, of course, the same thing goes with relay, goes with messaging. So I'll go here, set relay as the handler, put in incoming context here. And now any message sent to this number will be forwarded to relay. This is one little thing you might want to notice. Here, as the accept incoming call setting, we do have you set voice calls or faxes, but that's mostly for label usage. If you're using the dual mode and you're doing fax detection, just leave voice calls on and detection will just work. This is mostly for the label usage type of thing. Of course, if you're sure you're going to receive faxes, if you set it to fax, it will set the correct codecs right away and make it slightly more effective, because faxing is, as you know, sometimes you end up retrying and etc. What's interesting to look at is one last thing I wanted to show you regarding messaging, which might be my keyboard is not working anymore. Interesting. Woo! That's the case. Sorry for the interruption. My keyboard decided I wasn't worthy anymore. I wanted to show you this. So when you're sending a message, well, of course, you're able to debug the various errors, etc. Where is it? I don't remember if I have an example for this. Well, anyways, there's a way to set a. There we go. Okay, found it. Sorry. Event handlers. So there's an event handler saying on message state change. So you can, if you implement the method named on message state change on your consumer, you will receive message information when a message is queued, sent, and delivered. Of course, a message being delivered, as you know, doesn't mean the person has seen it, because that's not how messaging delivery works in general, but it's a good indication that the message will at least reach the device. So usually most messages will end up in delivered state. Or if there's a failure, it's going to be pretty clear. Generally speaking, failures are almost only at the carrier level. So relay, well, it's relay itself, the protocol. The clients, of course, are open source. So by virtue of that, the protocol is open source. The protocol is then being modified and changed, though we're staying within the backwards compatibility areas, of course. But the protocol itself is open source in the sense that the clients are just scripting languages, so you can take a look at that. I don't think there's an official documentation on the protocol itself yet, because we're still finalizing some of the more complicated reconnect stuff. But we're going to release something with about that soon with the new SDKs. Still, Relay is open source, yes, in the sense that it's clear text, so you can we will document it because anyway someone will reverse engineer it anyways, so might as well. What else? So just a few quick examples we could take a look at. Any plans on a on C++ SDK? Yes. Also a Java SDK. Those are all coming with iteration of with version 3, which will probably be Q1 2021. But yes, we're also looking at the Java one. In the meantime, you could use the C# one if you're on Windows or in a compatible environment. Or the Python one is quite good, and building C mining is probably not too hard. I just want to take a look at a few of the examples I have here because there's some of them are really quite interesting. For example, we could take a look at the event example. So this is what we saw earlier, the wait for ending example. This allows you to wait for the end of a call. What does wait for ending means? So what happens here is that you see there's a play TTS call after the wait for ending call. What this actually does is the following. If you this is an incoming call. So I am calling into this consumer, and this consumer is calling Bob. So I'm Luca, and he's Bob. Bob is on the other end. So if Bob hangs up, I'm still on the line, and I will hear that audio. Call execution will continue. Of course, if I hang up, then I won't hear the audio by definition. So this is a tricky but interesting thing. If a call is done, if we connect to a call doing a dial, doing a connect request, we actually get control back when the lag ends. And aside from checking if the call was successful or not, so if a successful dial will mean the call actually did connect. So I'm talking to Bob. Then Bob hung up, and after that, we resume control of the call, and we can do whatever. This could be useful for various items. There's so many use cases you could work with. So there's a lot to do here. Still, that's pretty much the nutshell of getting started with Relay. I know it's a lot. We're hitting time more or less. So since we started 5 minutes late, I would like to leave a little time for questions if there's anything I can help with other than the other questions that came up in chat. So I'm here. Anything I can help you with? Come on, don't be shy. Let's have one question. Oh well, I guess I guess the exposition was crystal clear, or rather, there's so much to process that people are probably already poking at the SDKs, trying to get something to run. So yeah, okay. Stephen's section about support for stereo end to end. So this is not really a relay thing; it's more a SignalWire. It's more a SignalWire thing, and the end to end stereo. I will have to check for you. I think we don't do that. We have separate channels for call for the two legs of the call, but not stereo and not end-to-end stereo. That's something that's probably available through pure SIP though. So if you'd like to come back, I can come back to this in just a minute and let you know. I honestly don't know. That's changed recently. So I'll take a note right now and see if we can get you something. If you could just, my email is Luke is on the screen. I'll make it bigger. Not getting bigger. Yay! So when I zoom the screen, okay, yeah, just drop me an email there, and I'll be happy to. Thank you, Kat. Drop me an email, and I'll be happy to answer any of those questions because I need to check about. So Vince was asking about the implementation of a hotline. Hotline, I think, meaning an IVR. Or distribution line, so that you get a call, an inbound call, and get to go out. Yes, absolutely. What I would recommend there is doing a SIP, uh, registering a number of SIP endpoints using our SIP system, and just have those agents registered to the SIP, and you distribute calls to relay. Or another thing you could do is just call them on their phones. But yeah, definitely, that allows you to not run a PBX. All you run at that point is a Ruby or JavaScript or Python or C# script that will distribute calls for you. Good. So I'm happy if we all learned something today. I'm very excited about Relay. By the way, the product we're using to do the workshop itself, which is SignalWire work, under the hood is using Relay to operate. So the that's what's coming in the future of Relay. There's so many other features, and they're coming down the line. I'll be happy to help. Yes, but I'm happy to help with anybody setting up Relay, anybody setting up SignalWire too. We have guides, we have information, documentation. So again, drop me a line. I'll be happy to help you or put you in touch with whoever can help you. We're always here to help. My main goal is to get people on board without any issues. So any questions you have, our wonderful support people will help you, like they helped me today. And thank you so much. And I'll be looking forward to the next installment where we do a more complex full relay application from start to end in December. Thank you very much. November, sorry. Thank you very much, everybody.